Hello and welcome to today's web seminar, How Visual Testing Makes Your Mobile App Stand Out in a Good Way, sponsored by Kobiton and featuring Frank Moyer, CTO of Kobiton. I'm your host and moderator, Sarah Crocker. Before we begin our presentation, let me explain the console. The panels on your screen can be moved around and resized to your personal preference. At the bottom of your console is a widget toolbar. By clicking the Handouts widget in the middle, you can download a PDF of our speaker's slides. If you experience any technical issues today, please let us know by typing in the Q&A panel on the left. This is also where you will submit questions for our speaker. There will be a Q&A session at the end. You're free to answer or enter your questions at any time during the presentation. To optimize your bandwidth for the best viewing experience, please close any other applications you might have running in the background. This event is being recorded and will be made available to watch on demand. Once the recording is ready, you will get an email with instructions on how to access the presentation. And with that, I'd like to hand it over to Frank.
Great. Thank you very much, Sarah, and thank you for all the attendees for joining today. My name is Frank Moyer, as Sarah mentioned. I am the CTO of Kobiton, and I've been with Kobiton for about 3 years. I've been in technology for about 30. I graduated from Columbia University with a Bachelor of Science in Computer Science with a specialty in artificial intelligence. So I've been enjoying this field for many years and look forward to talking to you today about visual testing. So I'd like to start out and just ask in your mind if you see any bugs with this screen. So this is the REI application, and it's how this application is rendered on the Note 8 on the left and the Galaxy J5 on the right. And I think it's pretty apparent what you'll see is that certain fonts are larger than you'd expect them to be on that size device, that there's padding that is incorrect. And overall, you could probably create about 4 or 5 bugs in this screen. But let's go on to this next screen on this device. And do you see anything here? It's not as apparent, but you can see that the enter note field is cut off slightly by the virtual keyboard. This is a common error in mobile applications where the keyboard, in the best case, just cuts off part of a field, and in many cases cuts off the actual button that's needed to go to the next step in the flow. And then let's go to this one. So, how about this? This is 2 versions of the same app, and you can see the difference here. It's pretty apparent, although a little bit more difficult to catch because the text is the same. It's just the wrapping is slightly different. And, this is an inadvertent change. The developer did not mean to make this change when they made a change to this screen. They added, or they changed the padding so that made the text wider, and it made it wrap differently. And then finally, this one. This is another same app. 2 releases. The right-hand side has a change to the left-hand side, and it looks like they're the same screen. But if you look more closely, what you'll see is that this text has been, again, inadvertently moved slightly from where it was in the previous release. That was not the desired change. The text is actually off-center with this revision, but it's very difficult for the human eye to detect that this bug was created, that this change occurred. So today I want to talk to you about what this means in terms of visual testing and what the different aspects are to visual testing, with manual checking of the visual component, you really need a source of truth, right? You need to show that this is the design that it should be adhering to, and you need some way to compare what is actually being rendered to what is expected. It could take hundreds of hours per release if you want to, and it does for some of our customers, to manually go through and compare the source of truth or the expectation to what is being rendered on the device, if it's done manually. And as we saw in that last example, it's easy to miss a bug, that the human eye does not have the ability to see things that sometimes a computer can see. And there are definitely times that a human eye can see things better or can understand what's going on the screen better than what a computer can. But we're going to talk today about how we can use technology to our advantage to make your application stand out in a good way, to make your application look like the Uber application, to make it look like Twitter, to make it look like Facebook, to make it look really, really great, and not just, and across a variety of device types. One of the challenges that we'll also talk about is mobile, and how mobile is different than web testing when it comes to visual rendering of the application. And I'm going to jump into two main aspects of visual verification. Along the top are releases of your application. And with new releases of the application, the job is predominantly around checking that changes were not accidentally or inadvertently made. And along the vertical axis, you have different device types. And here I'm going to talk about a concept that's new to the industry and something that Kobiton is a pioneer in right now. And it's around judging how a mobile device should render a screen. And I'll save the details for later, but it's something exciting that we're launching in the next month. We're going to talk about the tools to assist in checking, look at a few different tools, what the challenges with mobile are, how to judge across different form factors. And then we're going to briefly touch on the differences between scripting and scriptless visual verification. On the tool side, there are two tools we're going to dive into. One is the Applitools was the leader in visual verification. I think they were early to the market and have really pioneered some great technology with it when it comes to visual verification. And the second company tool we're going to talk about is Percy. And Percy was acquired by Browser Stack not too long ago and is being incorporated into the Browser Stack stack. We're going to talk about the different types of comparison that are offered by Percy and Applitools for visual verification. And we're going to discuss where to use those different types of comparison, like what scenarios you should use each. So the first one I'm going to go into is the Percy pixel comparison. And a standard, the old way of doing comparisons across different screens was to do pixel by pixel comparison. And what that means is you've got a screen that's 640 by 480. You have 640 times 480, every pixel that needs to match its RGB, each of its RGB alpha values across each of those pixels. So, in this app, we go back to, this is the same exact image. It's just the screen on the left is actually twice the resolution of the one on the right. So all it is 2x across the board. And when you actually do a comparison of these images, this is what you end up with. There's a lot that's very similar, The white areas, there's no difference. And in these red areas, there are pixel level differences. So that if you were to use the standard techniques for pixel comparison, you would get a lot of false positives, right? Because you're sitting there and you're looking and you're saying, well, yeah, but I can't tell if that was going back to the example we had earlier where the text was slightly moved. You can't tell that from this comparison because we're doing pixel level comparison. And you can see that actually in detail here, where you've got, the letter A, it's the positioning and the resolution of that A, and you can see these tiny little differences between the A on the left and the A on the right. So Percy, what they did was they actually add another level of comparison, which is called strict, and that it compensates for some of these anti-aliasing, what's considered anti-aliasing of the image on different resolutions. So they can identify that these subtle differences and not raise them as false positives. So you can see here on the left, you've got a list of products to purchase, and on the right, the same. It's a different list. And when you look at the comparison, you can see that a lot of the top area has not been identified, but the number of items that are different that is in the list is different, and it is highlighted. And then the individual products. This is, a screenshot from Percy to show the differences between the two screens. So, if you're testing, you can quickly assess that, okay, nothing was changed up here. I feel comfortable about this. I don't know about this. I know that there are content differences, but I can't tell if this, for example, this field was moved over accidentally a little bit to the left or to the right. And so when you look at those are the two main comparison levels provided by Percy. And so in summary, it does a very good job of accurately comparing static content, so that where you've got it's non-dynamic, it's a specific value, and it doesn't change from one rendering to another. It's got Percy has a very easy to use interface, and it's very good at identifying those accidental or inadvertent changes that a developer may make. And I think it's very effective to use this in a pre-commit type environment where before you go and you commit, the developer commits their code, and they just want to go and test it against a few different a few of their screens to make sure they didn't accidentally mess something up. It's a great tool to do that. But we did see the drawback, which was there's a lot of false positives with dynamic content. And that's going to segue into Applitools. So Applitools, again, has been around for a very long time. They are one of the pioneers in the space of visual testing. And Applitools has a few different comparisons. Similar to Percy, they have a strict comparison. It renders slightly different in that it's showing content values, but it's showing these pixel level content values across these two screens, these two versions. And if you go on they also have two additional types of comparison. The first is layout, where they can identify where the content might be different, but the layout, the content might be different, but the layout has adjusted and in a way that was not expected. So here, this pink area, they've identified that this has moved down slightly from the version on the left. And that saves, a lot of time. You don't get a lot of false positives here because it's not comparing the content. It's purely comparing the layout, and it's able to identify that. They also have the ability to compare the content. So here it's a comparison of not the layout. They're not looking at the layout. They're looking purely at the content. And that looks much more like the pixel level that we saw before, but it is looking purely at the content values in here. But what about across different devices or different screen resolutions? What happens there, and how do we handle that? In the case of Applitools, where you're looking at content, and this is the same. This is a content comparison, not the layout comparison, and you're looking at two different device types, different screen resolutions, and you can see that you get a lot of noise because the content is different. Even up here, where it's the same content, right? It's the same text in the search box, but it's highlighting it as a difference. These icons at the very top are also highlighted as different, even though they're the same. They're the same icon. It does a much better job when comparing two different screen resolutions for a mobile device across when you're using the layout comparison. And here, what's interesting here is it identifies that everything, even though there are differences from a content perspective in the top area, if you were to do a pixel comparison here, you would identify. You can even see that this horizontal scroll, which is right below the search bar, it's not as high as the one on the right, and it's got more elements on the one on the left does than the one on the right. So it's obviously different. So it identifies that. It doesn't raise any errors there. What is interesting is when you get to the bottom, when you're looking at this bottom section where it says try Flipkart or continue in English, it highlights those as differences. And it looks like what they're doing is they're starting at the top and they're going down on the comparison, and then they don't recognize that this bottom area, the try Flipkart, is pinned to the bottom. So there, again, we raise a false positive for this section at the bottom. And this would happen across, any sort of like tab area as well. So, finishing up on Applitools in summary, it does a very good job of supporting dynamic content. It's got a very intuitive and easy to use interface. It understands the layout of the screen, although when you start to get to the bottom part of the screen, if there's anything that's pinned to the bottom, it doesn't identify it as well. And it has an annotation tool that allows you to capture baselines from release to release. I'd like to just dive into mobile testing versus browser testing and how they differ in terms of visual verification or making your app look great. And if you look at the number of permutations of testing in a browser world, you're looking at maybe 3 to 6 browser versions and 3 to 6 different browsers across 10 different browser versions. So you're looking at 30 to 60 combinations during your test. And if you have a test of, let's say, 20 screens, you're looking at about 600 some odd screens to visually compare. When you look at the mobile testing space and across multitude of devices, you're looking at thousands of device types and tens of versions, plus you've got moving devices, limited CPU, memory, crashes. A lot can happen on a mobile device that needs to be verified visually. In this case, instead of the few hundred, if you had a test with 20 steps, you're looking at 20,000 some odd screens to compare across different screen resolutions and device types. Some other key points on the mobile side that differ from web is that mobile applications crash. That will change how the visual verification is done. You're going to expect to see a certain screen rendered, and it's not rendered that way. The median App Store rating is 2.6. There is a place for people to complain about the user interface. I work closely with one application that the user couldn't log in because of the button below the virtual keyboard issue. Very common issue. Crashes and poor performance are some of the main issues. And the App Store, 73% of crashes in the App Store occur because the app was not tested on the device type that crashed. I think this is an interesting story. We have one customer at Kobiton that has over 1,500 devices. They have every major device in the market, and they have to go through a process, and they do this manually today, where they visually verify their application across those, not all 1,500 every release, but predominantly most of those devices every release. They have a team of 100 people working around the clock to test their mobile application. It is a mobile-first company, and getting the UI incorrect has a significant impact to their business. But most companies don't have the capital to invest in 100 testers around the clock to test their mobile app. Nor do they have the capital to even invest in a user interface design that can be used for each device type and each screen resolution. Our customer here actually has UI designers who design every screen resolution to make sure, and on each operating system, to make sure that the screen is rendered exactly to their specification during the design process. And that leads to the next topic, which is, how do we judge? We talked about checking, right? This process of going through and for every release, verifying that the UI or what gets rendered hasn't changed or hasn't changed in a way that's incorrect. So how do we move beyond that and go to actually judging how your UI on a mobile device looks when compared to your competitors, or looks compared to the industry leaders? And I come back to this example. How do we know that, or how would a tester know that what is on the right-hand side is a bug? How do it's, some things are apparent, right? The fact that the no thanks overlaps the login and the create account, that the login and the create account are close to the bottom, and it looks like there is a shadow, a shadow that's created there, and they're in some way occluded. And then this text lays on top of this background image. Up here it doesn't. It's easy to see. Here it's very hard to read. So those are some more obvious ones. But what about this at the top here, where there is no buffer on the left-hand side? There's no margin here. This text looks pretty big, but again, then it's more of a judgment. And how does the tester know to judge the right way, unless they have, back to the point about having a source of truth? And for many organizations, they don't have the capital to produce screens for all designs for each of the screen resolutions necessary. So the tester's left with the unenviable job of guessing what looks good. And in many companies, the UI designer will come back through and perform some tests to make sure that it meets what they had intended. But again, that's a lot of back and forth between the designer, the developer, the tester, and back around again. So wouldn't it be great if your app, when you were testing it, if you could tell whether it adhered to the same UI design standards as the mobile elite? You could tell whether your app was similar to, in terms of how it's rendered across different device types, to Uber, to Twitter, to Amazon, Walmart, Facebook, to all of these companies that have invested millions of dollars in making sure that their user interface is a great user interface across each screen resolution. So I'm happy to announce that we are launching a what beautiful is machine learning model. And what we've done is we have trained a machine learning model on the top 50 apps across 20 different screen resolutions to start. So we've taken those 5 plus another 45, and we've evaluated them on different aspects of UI design, including font height, margins, color contrast between the font and the background. And we've bundled all that together into an outlier detector. So the ability to identify when something is out of the normal compared to, for a given screen resolution, compared to what the mobile elite has designed. So if you go back to, I'm going to go back to this previous slide, sorry. So here, knowing that this font is very large and probably a little bit, it looks to me quite out of line in terms of its size compared to the Note 8. Our What Beautiful Is model will be able to detect that on a Galaxy J5 screen resolution, this font is too big. And it will recommend to the tester to create a defect to resolve, to reduce the size. It will also provide the user interface for the tester, if they say, no, that's fine, to annotate this and say, don't notify me about this again. So when we look at specifics around the What Beautiful Is machine learning model, this is an example of what the data that would look like when you find this issue. The data that Kobiton presents to you, to the tester, to show what the industry is, how the industry is rendering that font height across different screen resolutions, and then what this font height is across different screen resolutions compared to the industry. So you'll see here the center area is the average, and then the top bar and the bottom bar are within the outlier, within the norm, and anything outside of the bar is abnormal. It's beyond the norm and would be considered an outlier. So what this says is, when you're on this specific screen, on a 480 by 800 or a 540 by 960, it is within the norm. When you start getting to the larger screen sizes, when you start getting up to the 1080 by 1920 and the really large screen sizes, the size of this font is much larger than it should be, or much larger than what the norm is in the industry. So it recommends to the tester to go and create a defect, and you can go between each of these different screen resolutions to see the size and to see how it compares. We're doing this across a variety of features in the UI. So we're looking at the font height, the margins, the contrast, the margins on the left and the right, as well as the top and the bottom. We're able to pull out certain features like list views separate from other parts of the app. And then got a few more minutes here to cover off a brief description of what the differences are between scripting and scriptless testing, specifically around visual verification, and what that looks like for a tester. Both Percy and Applitools have an API where an automation engineer can call the endpoint to check against a baseline. So you can check your latest version against the previous baseline and identify any differences. There it would render the difference in the UI, and you can go and annotate that user interface. The same thing happens on the Percy side. They have an API where you can compare the previous version and the current version. Now, what that means is, that as we're moving into a world of scriptless or AI and machine learning aided testing, we're throwing the testers back into this world of writing scripts in order to call the API. So if you look, there's an integration between Applitools and one of the companies that Kobiton partners with called Catalan, and they use that. Catalan uses Applitools for web testing to compare the baseline against the latest version, and Catalan calls that API. So with Kobiton, we've taken a different approach, and we have a intelligent test automation product that allows a manual tester to run a manual session on one device type, and we use machine learning to identify the elements across a multitude of other device types, so that you don't have to actually write the foundational script. One of the challenges with scriptless automation with mobile, if you look at like Applitools, you have to instrument your mobile application in order to capture the screenshots. And so with the foundational platform that runs your automation in an automated way without doing any scripting, purely scriptless, you don't have to instrument your code to capture the screenshots. It's done automatically by the platform. So here's what it looks like. You can, when there is an issue, you can go in through a user interface, easy to use user interface, and annotate. We capture that as the baseline plus your annotation, and we remember that for that, not just that device type and that test, but for all tests that use that screen. So we can identify what is a canonical view of a screen in a mobile app and different states of that screen, so that you don't have to get this same issue, the welcome text that's larger than it should be, raised to you, a bunch of times. The other capability that we provide is certain things that are right now need to be done manually within Applitools. Like you need to annotate dynamic content. To ignore it, because of we have the underlying platform, we can infer that where the dynamic content is. So we don't have to raise test execution issues that may be bugs if we know that there's dynamic content. We can use the equivalent of what Applitools is, the layout comparison, and then focus the content comparison on the static data. So the combination of the what beautiful is machine learning model combined with the the inference, the ability to infer dynamic content versus static content on an app will save the tester a tremendous amount of time. So I blew through that about 10 minutes faster than I thought I would. So I would like to open it up to questions.
Alrighty. I have a question here. How can we control these machine learning features? What to validate and what not to validate? Meaning, if I only want to validate fonts, on-screen resolution, and nothing else.
So right now, we do not separate those out, but I think it's a great idea to have that as a parameter when we run the machine learning models, to be able to say, I don't disregard all font heights. We've got that under control. And I think over time, one of the things we're doing at Kobiton is we're capturing all of these annotations and we're feeding those annotations. We're feeding those annotations into the machine learning model. So it's what's called online learning, right? So we're constantly learning from the annotations being provided by the testers.
Alrighty. Can you share any insights into common formats on the top 50 apps and common mistakes for other apps?
Yeah, so it's pretty interesting through our analysis. We have because of our intelligent test automation platform, what we do is we run a manual test on, just so everyone understands how we've seeded the actual data. We run a manual test on one device type, like a typical one we'll use is a Note 8. And then we will rerun that across a bunch of other device types. And we did that, and we can match elements across different device types and put a lot of machine learning into that. And what we were able to identify through these tens of thousands of screens and features is that there are some common features that, like the minimum font height we saw, that it just doesn't go below 12. That's standard. It's not going to happen. The list views, and as far as the anomalies that we've seen, a common problem made by developers is that while the text in the list view area scales well and the icons scale well, the non-list views do not do very well. So they are predominantly, what developers will do is a multiplication, some arithmetic around the screen size, and compare that to the base screen size of the design, and it ends up yielding a much larger font than is desirable. So that's one of the most common ones we've seen. We've got dozens more that we embed into our machine learning models.
All right. What is driven by Kobiton and what is part of Applet Tools and Percy?
So we do not use Applet Tools or Percy within Kobiton. Because we have the ability to capture the actual screenshots. So within the Kobiton platform, every single step is captured. So we capture the screenshots, and I know we hadn't planned on it, Sarah, but is it possible for me to share my screen?
Yeah, you can. This gray button at the bottom,
Okay.
on the far right bottom, if you hover over it, it'll start screen share.
Okay. So yeah, I'll show you an example of our session. So when you finish, every session within Kobiton has rich information that's comes out of it. So if you look at, this is what we call Session Explorer, and it has every step and the screenshot of every step. It tells the actual step on the left. We capture CPU, memory, network information for each request. And so we use this underlying framework to capture the screens and to compare those screens using our own machine learning models. You know, when Applitools first started, it was the machine learning models were in their infancy related to screen comparisons. But now there are a lot more machine learning models to use, and it's a lot easier to build those. So we built our own, and the other thing is we built machine learning models specific to mobile. You know, these are the ones from Applitools and Percy are more comparison for general purpose, and ours are very focused on specifically on the use case around mobile. What's the next? Is there another question? Sarah?
Sorry, I was on mute. Do you offer a free Kobiton, free trial?
We do. We offer a free trial. It has, I think it's 100 minutes and 15 days. But to access some of these machine learning features currently, it's only part of the paid subscription. So, yes.
Okay. Our next question is a sample scriptless scenario you could share.
Yeah. So, you know, the best example is, let's see. You know, if we were to just take I'm going to go through a simple manual test and show you the results of what that looks like across a variety of other device types. And, you know, I tend to prefer the REI app just because it's such it's a good app that shows some differences. But this process is, let me go ahead and I'll start this. I'm going to choose again, I like the Note 8. It's one of my favorites. So I'm just going to go ahead and launch that. This tells you some of the, on scriptless automation, some of what we call guardrails, certain features that aren't utilized in scriptless automation yet. You know, pinch to zoom, setting the time zone for the manual toolbar. But as soon as I install, hopefully this REI app is around. It is. So I'll go ahead and install that. And while I'm installing this, the actual scriptless part begins once the app is installed. And we memorize, we capture all of the features associated with a specific action the user takes. So we're not using, although we do use coordinates, that's not how we identify elements across different device types. So, you know, you all are familiar with this screen right now. You've seen this a few times, but you know, I can go ahead and, for example, I want to buy a pair of boots. So I'm going to go in. That's the other cool thing about one of the scriptless automation features we have is we map pop-ups, system entitlement pop-ups like location entitlements across different device types. So if it's here it's asking me for to allow or deny. On an iOS device, it might ask for a yes, no. And so we have that mapping across every single device type. So I'm going to go ahead and shop products. I'm going to look for footwear. I wanted a pair of boots. These Chelsea boots are these are the ones I love. I'm going to buy those. So I'm going to use my 10.5. And we also handle scrolling. So everything that's happening right here on the screen, even as I scroll down, we scroll down and are able to, across the scriptless part, identify this button and click on it. So that's all through our machine learning. And then once I've finished that, I'm going to go ahead and go to my cart and check out. And so that's the flow. When I exit my session right here, I will be prompted for how many different devices I want to run this against. So, I have the top 5 globally, the top 10 globally, the top 20 globally, and this, I don't know what's going on with that X right there, but so I can choose the devices, and some of these are offline right now. But I'm going to choose the top 10. Actually, I'm going to choose the top 20 globally. And now that will go ahead and kick off to run against those 20 devices. And I will be given what we call test execution issues across those different devices. And just to our machine learning is really good, but no machine learning is perfect. And to design a system without assuming that you're going to have some issues in the machine learning, then your design is not good. So if you look at what we call the remediation, in this case, we couldn't find one of the elements for submission. So this makes sense, right? You're trying to click on login, but it's down here. Our machine learning couldn't figure it out. So all you need to do is click on this login and submit. You can also create a Jira ticket right there and let your developer know where the issue is. You click submit, and you can also specify different comparisons. So you can say, listen, I know this is a bug, ignore it for a period of time, and for 15 days. And then you can move on. The other thing we have is the text comparisons. So we will automatically compare text. We also have the scroll remediation. So sometimes when you're scrolling across different devices, it may not be able to identify it. So here's the boot. I can go ahead and submit this and be on my way. So that's this is the Galaxy Note 8, and on the right is the Galaxy Note 9. And you can scroll through the different screens here. So that was a long answer, but hopefully it was helpful to the group.
Okay, our next question, would it be possible to integrate it with existing Selenium or Appium-based frameworks?
Yeah, it's a great question. We are actually going to be releasing, not in this next release, but in our November release, the ability to specify a desired capability where you can define your baseline in the desired capability, and then we will capture all the screenshots. We will do the comparisons automatically. So when you've got, let's say you're running, you want to test on 5 devices. We will provide desired capabilities so you can link those 5 device types for a specific test. And we will use that to compare the screens across, for our What Beautiful Is machine learning model, to compare it across those different device types. So we are integrating with Appium to support that.
All right. Does Kobiton support Flutter apps?
It does. We just released a Flutter driver. So Flutter apps, Flutter apps are challenging because their locators, their element locators, are oftentimes dynamic. You can't rely on, and it makes it really hard for an automation engineer to automate. One of the advantages to our intelligent test automation, but there are two parts to our platform, right? There's just there's device lab management, where you can host your own devices locally. You can connect, 20, 50, 100 devices, 1,500 devices locally. And you can, especially in this time of COVID, where people don't have the ability to actually touch the devices, you can remotely come in and access those devices through the Kobiton interface. And you can have those devices around the world that you can connect to. So we support the Flutter app through a Flutter driver for device lab management, our DLM product. And for intelligent test automation, we also, because a lot of the features that we use to provide the scriptless part are visual in nature. When we can use the element identifiers, we do, but when we can't, we have other ways to identify it. So it does support Flutter applications as well.
Okay, next question. Does visual testing through Kobiton also cover accessibility testing?
So it is, while the What Beautiful Is model does touch on accessibility, it is not specifically targeted at accessibility. For 2021, we will, right now in our ITA platform, we have crash assertions. We will automatically detect crashes and raise a test execution issue. We have text assertions, so using OCR and allow you to remediate test execution issues related to text. We also have visual components that we're talking about now. We are launching performance assertions in Q4, and we plan on launching accessibility assertions in 2021, as well as CPU, memory, and network in 2021.
Okay, let's see. I understand the benefits, but in your opinion, is automation for visual testing ultimately required?
I guess it depends on how much risk you want to take. It's a simple, there are different levels of it. The simplest thing of just what Percy does, the Percy sold their business to BrowserStack with a very simple thing. Just compare one screen to the next, the screen, one version to the next version, and make sure I didn't break anything. It's an easy task to do, and it's very effective at helping avoid the risk of making an inadvertent change to your app. And I think that the users today have a high expectation around performance, around stability. They don't want crashes, and around the UI. There are millions and millions of apps in the App Store, and how does your app stand out in a good way? It's visual. That's it.
Okay. And how about visual test requiring scrolling? You might have covered that a little bit.
I covered it a little bit. So we support that. We stitch together the different parts as we scroll to do the comparison. Yeah.
Okay. I think we've covered all of our questions. Anything you'd like
Great.
to say to wrap it up before I close this
No,
out? Okay.
no,
Well,
I
that
appreciate everyone's time.
very good. Well, that will conclude our event for today. I'd like to personally thank Frank Moyer for his time and to Kobiton for sponsoring this web seminar. And of course, a special thank you goes out to you, our audience, for spending almost the last hour with us. We hope that you have a great day and look forward to seeing you at a future event. Thanks.